which says that a particle P moves in a straight line passing through a point O with a velocity of 4.2 meters per second. At time t seconds after P passes O, the acceleration a meters per second of P is given by a is equals to 0.6 t minus 2.7. Find the distance P travels between the times at which it is at instantaneous rest. So they're saying that the starting point is a point O, and then the particle is moving in a straight line. So I'm assuming this particle is moving rightwards and just keep moving in that direction. And they've also given us another information that when it is at point O, the velocity is 4.2. And since we're taking O as the starting point, that means that when time is 0, the velocity is equals to 4.2. Now, we know that whenever we integrate velocity, we get the displacement. So in this case, displacement is the distance. So I will write that as distance. But we are given the acceleration. So that means that we need to find out the velocity, and we can do that by integrating acceleration. So a is equals to 0.6 t minus 2.7, making velocity equals to 0.6 t squared divided by 2 minus 2.7 t plus c. So v is 0.3 t squared minus 2.7 t plus c. Now in order to find this arbitrary constant over here, we can use this information over here. So when we substitute the value of t, the velocity must be equal to 4.2. So 4.2 must be equals to 0.30 squared, which again becomes 0, minus 2.7 t, so 0 plus c. That means c is equals to 4.2. That makes that v is equals to 0.3 t squared minus 2.7 t plus 4.2. Now again, we need to integrate the velocity to get the distance. So distance is equals to 0.3 t cube divided by 3 minus 2.7 t squared divided by 2 plus 4.2 t plus c. Now in this case, I can already tell you that this c is equals to 0 because this is displacement. Now we know that we are measuring the distance from point O. So when the time is 0, the distance traveled must also be equal to 0. And if we substitute 0 for t, this will give us c is equals to 0. So d distance is 0.1 t cube minus 1.35 t square plus 4.2 t. So we have the distance equation. Now they're saying that we need to find the distance between the times at which the particle is at instantaneous rest. What that means is that we need to find out the time when the velocity is 0. So if you look closely, we have the value of the equation of the velocity. So we can equate that to 0 to get the time. So 0 must be equals to 0.3 t squared minus 2.7 t plus 4.2. So after using the quadratic equation, we get that t is equals to 7, t is equals to 2. So now we have the displacement formula, which is 0.1 t cube minus 1.35 t square plus 4.2 t. Other than that, we have the times when particle P is at rest, which is when the t is equal to 2 and t is equal to 7. Now we can substitute these two values for t back into the displacement formula and find out the distance traveled at these 2 points. So when t is equals to 2, the displacement is equals to 3.8. and when t is equal to 7, the displacement is equals to negative 2.45. So we started at point O, and then at t is equal to 2, we were 3.8 meters from point O. And then when t is equal to 7, we find that the particle is now 2.45 meters to the left. So if we were to find the distance traveled between t is equal to 2 and t is equal to 7, we would need to add 2.45 and 2.8, so we get this entire distance. So when we add 2.45 with 3.8, we get 6.25 meters, and this is the distance traveled between the times when particle P was at instantaneous rest.